starting day for us, enjoying this afternoon, and also you could say celebrating a new member in the scientific community at this level as a PhD. My name is Søren Eliasen. I'm deputy head of department here, and I'm going to be the chairman today, and that's why I start and take the word as the first. We have other experts that I will present in a moment to take all the scientific stuff going on today. But first of all, I will welcome Ditte, which will defend her PhD thesis, slightly covered all the time, the science of sandbanks on Dogger Bank. And then I will welcome the assessment committee sitting here. It's Professor Brian Wine from Lancaster University, UK. It was correct, Wine, isn't it? Win, sorry. And I hope you might say a few lines more when you are on the scene. And then Hans Lassen, which is the former head of the ICES advisory program. ICES is the International Council for Exploration of the Sea. And then finally, Professor Susse Geo, which is from this Department of Planning and ANU. Then I will say welcome also to the supervisors. Ditte has had no less than 3 supervisors. Peter Holm from University of Tromsø, and Maja Horst from University of Copenhagen, and CBS she was in the beginning. Unfortunately, Maja has illness in the family, so she's not able to be here today. And finally, Sten Sverdrup Jensen, which is from IFM and Aalborg University. And then finally, I will say welcome to you, the audience, and I hope you will participate by listening, learn, and continue the discussion today and later on. We hope this will be a milestone and be discussed further on. For the program for today, that's that Ditte gets the first 3/4 of an hour to present the work. And then I guess you will need a break, and we will have a break also, around 1/4 of an hour to have something to drink and a snack. And I'm not quite sure if it's just outside. We'll find out. It's just nearby. And then the floor is the assessment committee, and we are actually trying something new today. Namely that Brian Wine and Win and Hans Lassen, they have some questions and comments, but they have packed it in 5 themes, so they will actually theme by theme comment and ask you some questions. And I haven't tried this before, so let's see how this goes on. But actually, it's much closer to a discussion than just one-to-one questioning. And then finally, Susse gets the last word. Yeah. So and in total, the assessment committee got 1.5 hours to examine or to discuss your work. But this is a public process, so you, the audience, are welcome to put questions to Ditte, to the work also. But in order to be able to pack it in a logical way, I need you to inform me during the break that you will give a question to Ditte and more or less the theme of the question, so we can be sure that Yeah, exactly. So if you have questions, then please contact me during the break. And afterwards, when Ditte has der er lidt flere stole, hvis I ikke kan finde pladser. Afterwards, when Ditte has answered all the questions from the assessment committee, they will, well, we discussed what's the word, retire, go to the room nearby and make the final assessment, and we will then enjoy a reception here and wait for the final judgment. And then we can all celebrate Ditte and give the speeches that someone maybe want to make. So that's the program. Ditte, the assessment committee, and then the party. I will say we have a video camera and webcam on to grab Ditte and the discussions. It's mainly because we have colleagues in Aalborg that wanted to participate but were not able to come here, and a colleague in Greenland, and that's why we are transmitting the presentation. And that's why I hope also you will be able to take the discussion up here so our colleagues can follow it. Okay, now Ditte, please.
Thank you. Yes. Hello. I'm going to give you a few glimpses from my PhD dissertation, which is a study of some processes of developing scientific advice in relation to the implementation of EU environmental policy. Just to give you a brief outline of the talk today, I'll first talk a bit about research questions. I'll give a brief introduction to the main issues in relation to the role of science for policy, which is what I've been exploring. An introduction to some research questions, and a bit about how I have been studying science and its boundaries. I'll talk a bit about the research design and introduce you very briefly, give you an overview of the cases. Then I'll talk a bit about the findings, about how scientists have been making decisions about methodological approaches in the processes of developing advice. I'll reflect a bit upon scientific uncertainties in states and the role of scientists. And I'll talk a bit about how different actors in the processes have been managing the boundaries of science, between science and politics in these processes. And in a final discussion, I'm going to talk a bit about some democratic implications of these findings and discuss the prospects for a new role for science and for politics in such processes. Yes, first a bit about the general issues which I've been interested in, which is the role of science for environmental policy and the implications of such a role. A traditional commonplace understanding of science is that science is detached from politics. Science and politics are distinct domains, and science's authority lies in its detachment, its independence from political interests and institutions. And within this understanding, the role of science is to provide a neutral basis for political decision making. But with the increasingly central role of science in society, and this role is being debated, scientific advice is one of the areas where the boundaries between politics and science are particularly urgent and visible and often also a very controversial issue. The ways in which the relation between science and politics is managed is a core issue often in the debates about the extent to which the scientific underpinning of policies properly justifies the policies, political decisions. But while this traditional understanding of science is increasingly debated and questioned, then the notion of science as detached from politics and culture still underlies a range of policy institutions and practices in relation to scientific advice. For example, Waterton and Gwynne have studied how such an image of science has made it a tool in strengthening political unity in the EU. Attempts to provide a collective basis for EU policies have been challenged by reverse tendencies to reclaim national sovereignty. And here the image of science as acultural has made it a tool in attempts to overcome national and local variations. For example, in the form of a common environmental information basis for environmental policy. I've been wanting to explore these issues, and I've been looking into two overall research questions. First, what does the role of science in policy making, some of these roles that I've been talking about, do to the scientific process and outcome? How does it affect the actual practices? And in which ways are the boundaries between science and politics mobilized, transgressed, dissolved, and in other ways processed as part of this work to produce credible justification for policy? I'll introduce you very briefly to some of the main tools I've been drawing on in my study. I'll be studying the role of science for policy and here under the relation between science and politics in advisory processes. And therefore, the boundaries of science is an important issue. And I've been looking for a perspective which did not predefine what science and politics is, but rather enabled me to study how they became defined, how they were defined in the process that I will study. And for this use, the concept of boundary work has been really productive. It was introduced by Thomas Guerin. He argues that the demarcation between science and other activities is a practical construction. Scientists have an interest in demarcating science from other activities in order to underpin their authority, in order to gain access to resources and to maintain autonomy from political interference. And he's been studying situations where scientists have been defending their profession, and argues that there is a tendency to define science in relation to what it is not, which depends on the particular situation in which they've been defending science. So in that way, rather than being defined by inherent characteristics, science is defined in continual boundary work in relation to other activities. So it's been defined as not mechanics or not religion, and so on. Guerin talks about boundary work as a rhetorical style by scientists to defend their territories. But scholars like Sheila Jasanoff and others, they have talking about how in scientific advice, different kinds of actors have interest in taking part in this boundary work, not just scientists. And this engagement, and how this engagement in boundary work is not just strategic, a rhetorical style, but it also has to do, for example, with epistemic cultures. Another main source of inspiration for the research design is the field of laboratory studies. An underlying notion within this field is that science is socially embedded, and in order to study this embeddedness, it won't bring us far just to look at its products alone. We need to study science in the making. One of the main contributors to this view is who argues that once scientific statements are accepted as fact, their contingent and tangible the contingent and tangible processes behind their production, they become invisible, they are forgotten, and the fact stands alone and has authority. You could also say that statements are accepted as fact by being freed from their contingent history. Or you could say that the history behind the fact is black boxed. Laboratory studies then is, among other things, about opening these black boxes and follow the negotiations and the multiple ambiguities and complexities involved. Looking at scientific advice, scientific advice does not provide facts, but rather information for decision makers to base their decisions on, and advice seldom achieves the same stable authority as facts, and it's also not always widely accepted. So, but still it can be black boxed in other ways. Studies have shown how the authority of advice and advisory institutions is maintained by keeping some of these processes hidden to the general public. So what I have intended to do is to take laboratory studies out of the laboratory and open some of the black boxes in the production of scientific advice for environmental policy. Finally, I've been drawing on description as an approach in my analysis. Again, drawing on literature. I've been approaching scientific practice as performative, so the division of work between advisors and government, the claims to scientific validity and so on, they do not only show in the processes, but they are also shaped by them. So I have not set out to uncover generative mechanisms or underlying variables explaining what happens in the processes, but rather I wanted to stick to the kind of explanation which description can provide. Briefly about the research design. I've been studying the implementation of the Habitats Directive, which is an EU directive for the conservation of biological diversity. And the main tool in the directive is protected areas. The directive lists a number of habitat types and species which each member state is supposed to protect, among other things, by making protected areas. And one of these habitat types is habitat type 1110, sandbank slightly covered by seawater over time. And this has brought the Dogger Bank into focus. As you can see, the Dogger Bank is a major bank under sea level in the middle of the North Sea. It moves through the exclusive economic zones of 4 member states, the UK, the Netherlands, Germany and Denmark, and all 4 member states have been considering whether the Dogger Bank is a sandbank in their exclusive economic zone, and if it is, where on the Dogger Bank does it start to be a sandbank? And this drawing the boundaries of the sandbank in these member states is what I've been following, these processes. I've been comparing the parallel processes in the UK and Germany of drawing these boundaries. According to the Habitats Directive, these processes of designating sites are supposed to be an exclusively scientific exercise, which means that they are not supposed to consider social and economic implications when they designate sites. And a series of court cases further underlines this need. I've been doing my field work has been, I've been studying this by interviewing scientific advisors, environmental NGOs, and fisheries industry representatives in Germany and in the UK and in Denmark, because there are major fisheries interests on the Dogger Bank in Denmark. I've been observing consultation meetings between government and between the with the UK government and stakeholders, and I've been looking at legal documents, scientific reports and articles, minutes of meetings. Just very briefly about the cases. These are the resulting boundaries. The red line is the UK, the green is the Dutch, and the blue is the German. As you can see, the boundaries do not meet at the borders, and they bend. You can see that the scientific advisors have been following different principles for defining the sandbank. Also, the UK boundaries are generally much shallower waters than the German boundaries. And they've been following different, they've been working differently, I will argue in part because they've been working for different governments, because there are different stakes involved. Yes, just to say something very briefly about the stakes. On the UK, in the UK area, it's rather shallow. The other areas are less than 12 meters deep. It makes it a really good site for wind farm developments. And actually, the world's biggest wind farm has been projected there. It is expected to be able to provide 10% of UK's total energy consumption. And it's an important part of UK's strategy for a transition to renewable energies to fulfill their EU obligations. Also, it's an attractive fishing site. The German area is in much deeper waters, which means it's not interesting for wind farm development, and it's not an attractive fishery site, and not in the same way as in the UK, at least. But what is at stake in the UK, was at stake in Germany, was that by the time where the German advisors were asked to start this designation process in 2002, there was a Green government, and they wanted a very fast clearance on where these sites should be, because then they could decide where they should have wind farms. So the scientific advisors had to be fast. A very brief overview of the processes. The German process took 2 years all in all, including government approval, stakeholder consultation, and submission to the European Commission. It involved one version of boundaries and went rather smoothly through Parliament. The approach was mainly morphological, which means it was about the shape and the slopes on the bank. Generally, the boundaries were drawn where the slopes leveled off to the surrounding sea bottom. The UK process took more than 10 years. It involved several versions of boundaries. This is just 2 of them. It was highly controversial, and it involved a lot of negotiations with government. The approach was multidisciplinary. The boundaries are based on studies about morphology, hydrology, geological analysis, sediment samples, and biological communities. Good. I'll present you to some of the main findings. First, a bit about how the scientific advisors have been making decisions about methodological approaches, and I'll be focusing in this presentation on how they've been managing scientific uncertainty. When the advisors, they've been choosing between scientific methodologies, it's also been a choice between scientific uncertainties, and sometimes this choice has been strategic. And I'll give an example from Germany. They chose to base their boundaries on a slope analysis, which is this based on water depth and the shape of the bank, and not on a biological, on a study of biological communities. And they did so for several reasons. First, a slope analysis requires data about water depth, and they can be collected using an echo sounder. An analysis of biological communities requires data about marine life. So it requires sediment samples, video tows, or even stills and dives. A slope analysis is far the cheapest, and it enables more samples with a higher density, which leaves less uncertainty about what happens in between the samples. Also, a slope analysis can be made by feeding a computer model with depth data, which leaves little space for personal judgment. And this has been a really important objective for the German scientific advisors. An analysis of biological communities requires quite a lot of personal judgment about how to group the different communities. So by choosing a slope analysis, the scientific advisors, they wanted to reduce the amount of uncertainties, and they wanted to be less vulnerable to criticism about bias, to ensure that they had backing on their side. There have also been differences in how the uncertainties have been perceived by the different actors, and this has also affected the decision making about which methodological approaches to draw on. For example, where the German scientific advisors, they chose the slope analysis in order to reduce uncertainty, the UK government found that this approach left a whole array of really important parameters highly uncertain. The Department for Energy and Climate Change, which were in charge of UK's transition to renewable energies, they were really concerned about the prospects of a major site on the Dogger Bank, and they argued they wanted to know whether a bit about the extent to which the boundaries actually told anything about the marine life on the bank, which protected area was meant to protect. So the scientific advisors, they supplemented with an analysis of biological communities on the bank. To the left you see the first version, and then you see to the right the second version. This approach actually changed the boundaries on the bank, and the site became smaller. So it shows that the methodology that was chosen in Germany to reduce uncertainties was found by the UK government to leave important parameters highly uncertain. And this also shows which parameters should inform the boundaries depends on states and on contextual factors. These findings both support and undermine some of the main claims made by Funchowicz and Ravitz about what they call post-normal science. We've developed this model where there are two parameters. You have decision states, and then you have systems uncertainties. And they argue that where there are few uncertainties in decision states, scientists can just continue the routine work without considering the wider situation in which their science feeds into. But their role changes gradually as we move out of the axis, and when either of both parameters are high, we operate within the realm of post-normal science. And here scientists cannot make decisions in ignorance of the wider implications of their work. And Funchowicz and Ravitz argue that the validity of the science should here not only be evaluated by scientific peers, but also by an extended community of peers, which are those who have stakes in the outcome, in the policy decisions. They might, because of their involvement in the issue, they might have relevant experience to share, and their interest might create some kind of productive alertness. One could say that the examples from the Dogger Bank confirms this, particularly in the UK, where the uncertainties and decision stakes are high. The Department for Energy and Climate Change, for example, who has major concerns about the prospects of this site, because they want to have a wind farm. They're particularly critical about the informational basis for the site designation, and it's because of their interest that they have concerns about the validity of the science. But as a number of the science scholars have argued, really when Jasanoff, Funchowicz and Ravitz model presupposes that we know where we are in the model, whether we are in the realm of post-normal science or we are professional consultancy. And it presupposes that the quantitative values of either parameter can be settled. But these examples from the Dogger Bank cases show that actors do not necessarily agree about the kind and extent of scientific uncertainty, and also the two parameters are not independent. The stakes affect the ways in which uncertainty is assessed and the other way around. So who is to define where we are in this model, and whether we should involve stakeholders in the debate about scientific validity? Should scientists, or should government, or should stakeholder groups? So in this way, even though Funchowicz and Ravitz, they attempt to point to the ways in which science and policy is closely interwoven in post-normal situations, they also undermine their own argument by making scientific uncertainty and decision stakes some kind of objective parameters. And in this way, they also come to exclude an extended peer community from debates about their values. And one could argue that particularly stakes and uncertainties are issues which would be relevant to debate with an extended peer community. Then I'll talk a bit about how the actors have been managing the boundaries between science and politics. And I'll just give a few examples. According to the Habitat Directive, the designation process should be exclusively scientific, which means that the boundaries should be motivated by technical considerations alone and not by socio-economic considerations. So which kind of boundary work has been taking place in these processes? I'll give some examples from the relation between the statutory advisory agencies and governments. The German scientific advisors, they did not seem to have any problems with taking on this role as providing disinterested knowledge for policy. They emphasized the claim and the Habitats Directive that should be based on science alone, and they found that this claim made their job easy. This is an excerpt from an interview, a German scientific advisor who wants to talk about the development of management measures and not just about the designation process. He asked, he's becoming impatient with me, and he asked, are you dealing only with the selection process? And I said, I'll be focusing on the selection, and that's simply to do with, I have orders from my supervisor, stop broadening what to look at. And must be the German scientific advisor says that the selection is not too difficult. In principle, it's so easy, because you only need to follow scientific knowledge and logic, and also the procedure is so clear. The difficult part is if you come to the management of the site in line with the economic interests. That's really difficult. The German scientific advisors did request approval from the government at one point. They based this slope analysis on a computer model where they defined some rules for how the model should draw the boundaries, and they presented the government with a set of rules and asked what the government thought about this. That they presented it to government before they ran the model. So before they had found, before they could see the resulting sites, and hence also which implications it could have. This is the rules in the model, just so you can see which kind of consultation the advisors have made with government. The government didn't have really any comments on this, so they moved forward. Later, when they had designated sites, there were some ministries who had some comments, but they were told that their concerns about implications were not relevant at this point. The UK so the German scientific advisors, they've been very preoccupied with managing these science policy boundaries in their interactions with government. The UK, on the other hand, they have been negotiating with government a lot, and these negotiations have even been institutionalized in regular meetings with the Marine Biodiversity Policy Steering Group. This group consisted of representatives from the Environmental Ministry, DEFRA, from the Department of Energy and Climate Change, and with the Department for Trade and Industry, which are in charge of all the oil and gas licensing. One of the scientific advisors explained the purpose of the meeting with the group like this. It's the group through which we get government-level comment on scientific advice. So we don't have to take any notice of what they say, but it's useful to have a discussion with them. And they give feedback on things we bring to them. The reason for having this group is to try and guess what the response will be to these proposals coming through the cabinet for approval. That we want to have an idea beforehand if there are going to be problems, so we can have some time to resolve those if we can. The advisors consulted this group regularly, and they did take some of the comments into account. But they did not leave entirely to government to define the boundaries between science and politics. The Department for Energy and Climate Change hired an external consultant to assess the advice and the boundaries which the advisory committee had proposed. And he criticized the scientific basis for these boundaries and proposed another approach which resulted in a smaller site. one of the UK scientific advisors, said that this is an area where it gets into slightly difficult relations, because they were questioning the scientific justification. But because of the department that comes from, which is the Department of Energy and Climate Change, then it certainly would be seen as possibly taking socioeconomic factors into account. You know why they're arguing about it. So what the statutory advisory agency did was to hire 2 external peer reviewers who then assessed their own advice and the comment from this external consultant. At a first glance, it could seem like the German scientific advisors have been more preoccupied with managing the boundaries between science and politics. But the UK has also been managing the boundaries really carefully, and actually the negotiations with government can be seen as part of such boundary work. As they tended to see the scientific and political decision making as closely intertwined, then transparency and to some extent also receptiveness to government was, among other things, a means of ensuring that statutory advisors did not overstep their mandate as scientists and interfered in politics. So the German scientific advisors, they, on the other hand, they to a greater extent define the boundaries as being placed between the scientific advice on the one hand and then proper parliamentary politics on the other, where the UK advisors saw it as something happening in the development of the advice. Some of the same kind of boundary management can be found in a lot of the other processes, in the advisory reports, and in the consultation process, the stakeholders, and then among environmental NGOs and fishers. A general tendency, perhaps with the exception of the fishers, was that actors tended to debate the boundaries of the protected areas in technical terms. And this was in part with reference to the claim in the Habitats Directive that it should be an exclusively scientific process. The UK advisors did fear a case at the European Court of Justice in this regard, and the environmental NGOs did let them know that taking them to court was a possibility if they were too receptive to industry interests, for example. So in public consultation in Germany and the UK, they were only allowed to comment on the science, the stakeholders. Other case studies show that the implementation of the Habitats Directive is not that these boundary management processes are not particular to the implementation of the Habitats Directive. That it does make these more outspoken, as it's I'll talk a bit about some implications of these findings. First, a bit about the effects of the science policy boundary management we've seen in these cases. First of all, a number of more political issues were not discussed in this debate. For example, an issue which environmental NGOs raised in interviews, but not in the consultation process. I think I'll skip that. And another. An issue which environmental NGOs raised in interviews, but not in the consultation process, was that there was an issue in balancing the protection of the harbor porpoises, which that was a parallel process of considering whether harbor should be protected on the Dogger Bank, and then balancing that and a fast transition to renewable energy. So this debate was not brought up in the consultation process, which was focused on the technical details. So one of the effects of this need to stick to the technical discussions is that political issues escape the public debate. Another issue is that the scientific advisors are only held accountable for the technical element in the work. Even in the UK advisory reports, where much effort was put into ensuring transparency, they only account for the technical elements of the work, and not, for example, their debates with the Department for Energy and Climate Change. For good reasons, considering the legal framework. So, we might need some new ways to hold scientific advisors accountable of their judgments and to ensure a more democratic process. Transparency is an important first step in order to make scientific advisors accountable. But if we are to make them accountable also for the ethical content of their work, transparency needs to embrace the hybrid character of the advisory process and not only the technical part of it. And as Funtovics and Rabbits argues, stakes can be highly relevant to consider and stakeholders relevant to consult when making decisions about methodological approaches and how to weigh uncertainty and so on. But such formalized extended peer review will not necessarily reduce controversy. As these examples show, stakeholders' claims about the scientific validity are closely bound up with interests. So being in dialogue on the scientific methodology and the analysis, the resulting advice and so on, it involves, as with any other democratic process, navigating among different interests, including all the trouble this involves. Science is important. It's important as a basis for policy, like in policy fields like environmental regulation and risk management. Issues like climate change, declines in biological diversity, the relation between cancer rates and chemical substances in the environment, and so on. They require, among other things, scientific inquiry in order for us to be able to develop policies. Do we need boundary work? We do, and we need to be engaged continually in considerations about what it is that makes some statements more authoritative than others. We will just not arrive at any fixed answers about what it takes to scientifically justify policy. We will not arrive at answers that counts for any situation and which will be considered valid for all actors. It will have to be a continual negotiation. So which kind of mandate should we give to science? The mandate given to science in the Habitats Directive is that of providing the only legitimate basis for the designation of protected areas. But as we've seen, this is impracticable, and it has a number of effects. An alternative mandate would be to let science share the role as the legitimizing basis for decisions with politics, and request decisions which are both scientifically and politically justified.
Thank you, Ditte. Now there's a quarter of an hour break till 5 minutes past 2, and then we'll go on with the assessment committee. Yeah. Pretty sure that the refreshments is still down. I'll try it.